Today I am going to solve a LP problem, and this problem actually I have taken from a book, Managerial Decision Modeling Spreadsheets. With spreadsheets, it is written by Balakrishnan, and from that book this is problem 213, and here it says that using graphical procedure and using Excel, we have to solve LP problem. So here we have objective functions. It is profit equal to 2x plus y. So we have to maximize this, and it is subjected to three constraints: 3x plus 6y less than equal to 32, 7x plus y less than equal to 20, 3x minus y greater than equal to 3. As well, there is one non-negativity constraint. It is x, y greater than equal to 0. Non-negativity constraint means we have to work on first quadrant. So according to this mathematical formulation, I prepared one table. So it is written as x and y here. It is the two variables, and solution for this x and y, it will be written here. Right now it is 0. Objective function coefficient, it is these two coefficients are taken from objective function equation 2x plus y, and the profit we need to find. So this cell I put here 0. Subjected to the constraints, constraint 1, 2 and 3. So I have written all the coefficient of these constraints for the left hand side, and there will be value for this. So I wrote here left hand side, and here there is a sign less than equal to or greater than equal to, and right hand side taken from constraint equation as 3223, so it is here. Now for this yellow marked cell, we have to find the values. So for these four we have to use a formula. So in next worksheet we can see that sum product of these two cell, comma, as well these two cell, but these two cell to be locked, because this cell, it is absolute, it will be used for all these rows. That is why in all the cases this is locked with $sign, because G10 H10 these two, G8 H8 these two, G6 H6 these two, but this G5 H5 for all it is this one. So once we get the value, so now right now this is 0, so surely all this value will be 0. Say we can see in the next worksheet this one, actually it was 0. So what I will do, because already I used solver, so I am using it again. I am putting here 0, here also 0, here I put 0, so all 0 now, all values now 0. Now I have to find those value. So how to do that? We have to go for clicking on data, then you go for solver. Now this is the solver I have. So already there is address, already there are some values, it is here. I want to remove this, delete, because I will do it again. delete and delete. Okay, but other value will be as it is, because this set objectives always it will be this one, because our target is to find this. That is why it is I6, this I6. So it is selected for this set objective, this place. Now by changing variable cell, it will be these two. That is why it is G5 H5. So G5 H5. So here we will select these two. Now here we have to put subject to constraints. So what we will do, we will click on add. So it says like this. Now we have to select left hand side and right hand side. So left hand side I select here, and right hand side I select this. In between there is sign this one. So it is okay. So add this. Again for left hand side this, and for right hand side this, in between this sign. So it is okay. Press add. Again for this third constraint, left hand side, but this sign are not same. So we have to change this greater than equal to. Here it will be this one. So all are done. Add. So 3 are added. So let's go to our solver sheets. So it is here. See, these 3 are selected. We will select a solving method, simplex LP. Now if we press solve, value will be generated, but they are asking some additional points to be selected or not. Say keep solver solution, we want like that, and we need report for answers, sensitivity, limits. Okay, so we got it. So now okay, within seconds it is generated. So we got the value, solution value 2.3, 3.9, and objective functions, this profit value in maximized condition we got 8.5. Other values also generated. So here, as I mentioned before, I asked for some reports, say answer reports. We got this answer report. It is engine simplex LP. Objective function, already we have seen our value was 8.5, and solution value for x equal to final value it was 2.3, 3.9, constraint 3, constraint 1, and constraint 2. According to this formula, so we got this cell value and status in terms of binding, non-binding, and binding. I am not going to discuss right now for this one what is binding, what is non-binding. So for the sensitivity reports, we have to see for the value of x and y, 2.3, 3.9, already we have seen that reduced cost is 0. And constraint 3, constraint 1, constraint 2, we got the shadow price. Allow will increase, allow will decrease. Just only I am reading this, I am not explaining all these terms, when to use it and what is the use of all this value, shadow price, reduced cost. It will be discussed in other videos. limit reports, it is objective function coefficient. We know this value we got, that one 8.5, x value, y value 2.3, 2.3. So our objective result is 8.5, 8.5. So we got 3 reports. So we are now in these situations. So we solved it using solver. Now we can get all these values, I mean 2.3, 3.9 or 8.5 by graphical procedure, by using graphical procedure. So let's move ahead to see how to get that. So here we got a graph. It is empty graph having x-axis and y-axis. In the right hand side I have shown objective function, what we already discussed, and there are 4 constraints with one non-negativity constraint. So for graphical solution, it means we have to plot first all these constraints. Then we need to identify the feasible region. When we finish the graph according to this constraint, then we will identify feasible region. Then we will plot objective function. Once we finish objective functions, then we will try to find the visual optimal solution. Then at an end we will find algebraic optimal solution. So here as we know, if we want to plot a line on this graph, we need 2 points to draw a line. So the 2 easiest points are the intersection between the linear equation and these 2 axes. It is the most easiest way to find. So what we will do, we will select, say for this, first we have to convert inequality to a linear equations. All these equations, inequality to be converted to a linear equations. So I did that. 3x plus 6y equal to 32. This is 7x plus y equal to 20. 3x minus y equal to 3. So for the first line, as I told, we need to put for x-axis, we have to put y equal to 0 and there will be value for x. So if we do this, y equal to 0, then x equal to 32 by 3, it comes 10.67. Again for x equal to 0, If it is 0, then y will be 32 by 6. It is 5.33. So our point is 10.67, 0. So we will plot a line. Look at this, 10.67 here. It is 10.670 and 5.33 value for y, x equal to 0. It is on y-axis. So this is 5.33 and y-axis value is 0. So we got the line 3x plus 6y equal to 32. This line we got. Now for the second one, if y 0, then x equal to 2.86. If x 0, y equal to 20. It's very clear. If x 0, y will be 20. So our point is this one. I mean 0, 20 and 2.86, 0. So I am drawing the line 2.86, this point, 0, and this is x value 0, y value 20. So this is this point. So this is our line. So we got two lines. If we were given only these two lines, so of course our feasible region will be this. If we had only these two lines. But we have now another line also. 3x minus y equal to 3. In this line, I want to mention one important thing, that here there is a minus. But as we know, we will plot on first quadrant. So our all value will be positive. So be sure with just considering these points. These 2 points, it will be taken in such a way that these 2 points comes on this, because this equation, if we plot, line will be like this, going in the down even. But we don't need that area. We want to plot it here only. So what we will do, if y equal to 0, look at if y 0, x equal to will be 1. So point is somewhere here, 1, 0. And if x equal to 3, y will be 6. Very clear. If x equal to 3, if x equal to 3, y will be 6. This point will be somewhere here. So if we plot that, if we plot the line, it comes like this. So we got this. Now 3 equations intersecting here. So where is our plots? Which area is the feasible region? Our equation says z equal to 2x plus y. So it looks like here x is more powerful, more profitable than y, because it is 2x. It is y. So x is more profitable. So our regions will be in this side. So this is our feasible region. I put some color on it. So this is the feasible region we have. Now we got, so our target now is to draw the objective functions. We have to draw the objective functions. I mean this one. How to do that? We have to assume some value, because objective functions, it will be like this way, this way. So we have to assume some value say what we will do, we just objective function say x equal to, say x equal to 2, y x equal to 2, because looking at the feasible region we have to select the value, because we intend to draw objective function like this, so we need 2 points like all these lines. So here we have to select one line in the center of the feasible region, center area. So center area means we can consider say x equal to 2. It is middle of the feasible region. So if x equal to 2, of course y equal to 0. So then we can see here, look at this, if at x-axis x equal to 2, y equal to 0, then we have to calculate the value of z. Value of z how? Why? Because we need another point to calculate. First point we already assumed it is 2, 0. So x equal to 2, y equal to 0. Now we want to find z, because we will use this z value putting here, and we will find another point on y-axis. That is why after getting the value z, I put z equal to 4 equal to 2x plus y. So assume 2 into 0, because y-axis, on y-axis point means x value 0. So easily we can put here 0. We can find y. So y equal to 4. So point on y-axis will be 0, 4. It means this one, this point, and here 2, 0. Now I can plot this. This is the objective functions, because it is taken from objective function equation, and assuming here one points middle of the feasible region, then this, using this value we found the value of z. Then again putting the value of z in this equation and considering it is on y-axis, so x value 0, easily we can find y. That is why calculation showed like this. So 0, 4. Now it is done. Now since we want to maximize, because we want to find visual optimum solution, so we'll push this objective function line far from the origin, far from this 0, 0 towards these points. This is our target. We want to maximize this value of z. I mean this objective function. We want to maximize this value of z. So we push this objective function as far away from the origin as possible, to maintaining the same slope also. We will not push in such a way that this line will be tilting. No, we will move or push in such a way the slope will be same as this one. So say in that case, say I will push this line somewhere here, so I have to assume some value. Say I will move here like this. So we have to assume value on y-axis, I mean x-axis. Say it is x equal to 4. I am taking x equal to 4, so y, of course it will be 0. It is on x-axis. Now you put this value 4, 0 on this equation, z equal to 2x plus y. So what is the value of z? You get 8. Now using this value z in this equation, we can write 8 equal to 2 into x, as it is on y-axis point we want, so it will be 0, value of x will be 0, and we can find y, so y equal to 8. So our point is very easily come 0, 8. So here we assumed first 4, 0, on y-axis it is 0, 8, keeping the slope same as this one. We did not change the slope. We maintain the same slope. That is very important when we push the line. So this is the line. Look at 4, 0. 4, 0 is the x-axis point and 0, 8 is the y-axis point. But we did not find the line touching this corner points, because our target to reach this line up to here, to cross this. So because we will move this line to leave the feasible region, then we can guarantee that this is the optimum solution. This node is the optimum solution. So what we will do? We will assume another value now. Say, before I assumed x equal to 4, now I will assume x equal to 4.25. So if I assume 4.25, y equal to 0, of course here. So what is the value of z? 2 into 4.25 plus 1 into 0, it is 8.5. This is the value of z. Now using this value of z in the equation, considering that on y-axis x equal to 0, we get the value of y. So we got point on y-axis, we got 0, 8.5, and x-axis point is 4.25, 0. So we can draw a new line. Look at this black color line. This is our targeted line. This one, for this line we push this line. So once we reach here, now if we push more, it will cross the feasible region. So already we got this. I mean, extreme end, we got this objective function. Now we want to find algebraic optimum solution. To locate the point, what is the coordinate of that points? That is our target now, to find this, because already we reached here and we found that this is the optimal solution. It is visually we found, but algebraically we want to find what is the value for this. That is why algebraic optimal solution, it occurs at these corner points. So we have to take, because these two lines, this line and this line, I mean 3x minus y and 7x plus y. So we have to take these two lines, this line and this line. Look at the equation. Now you see 7x plus y, 3x minus. Actually our target is to find the value of x and y, I mean these intersecting points. So if we add this, y cancel, so 7 plus 3, 10x equal to 23. So x equal to 2.3. Now if we put this x value on this equation, 7 into 2.3 plus y, we get 20 equal to 20. So easily we find y equal to 3.90. So we know now this point is 2.3, 3.90. This point. Again, putting the value of x and y here, if we put x and y value here, what we got here, then we get the value of z. It means profit. 8.5. By algebraic optimum solution, we got these two: x value, y value, and z value. That's all for today. Thanks for watching.